great to be here. Very, very nice to be in Medellin. I'm going to talk about JavaScript at 20. It's 20 years old. I started it a long time ago in a hurry. And I like to recall Ian Hickson's signature line, things that are impossible just take longer. And that's true on the web. Web standards take longer, especially if you have to deal with Microsoft in the 90s or Netscape going out of business. But things are better now. In 1995, I was tricked into going to Netscape to put Scheme in the browser. Who knows Scheme, the Lisp-like language from Guy Steele and Jerry Sussman? Very good, yes. So some friends from Silicon Graphics were at Netscape, and they said, come on, come out and put Scheme in the browser. And I said, OK, I'll do that. And then when I got there, they said, oh, we're not sure we really meant that, because now we're doing Java. And so if you do it really fast, maybe we'll believe that it's worth having another language besides Java. Oh, and if you do it really fast and make it look like Java, then we might believe you. So I had to do the prototype for JavaScript in 10 days for a demo to convince people in the company that it was worth having two languages, which caused me to lose my hand and part of my shirt. I got better. That's me a long time ago, about 40 pounds ago, maybe more. It was the 90s. Things were moving very fast. Netscape had to go public in August of 1995. I did JavaScript in May, and we were causing a lot of excitement around the web because we were making the first commercial browser. After NCSA Mosaic, we had secure sockets layer, we had JavaScript, we had Java coming. Java was supposed to be the big language, and JavaScript was the sort of sidekick language. That's changed. But in those days, everyone thought Java would be what people wrote their serious code in, and JavaScript would be this little toy. It didn't work out for Java. Java became that. And a lot of plugins are like that. Sometimes JavaScript's like that, too. But Java is very slow to load classes, and it's become a malware vector. So it's nowhere. It's not on mobile, except for apps, but not as a plugin, not as a web thing. When I was at Netscape in the first month or so, I'd go to read computer science papers at Margaret Jacks Hall, the old computer science hall at Stanford University. And I read this paper by James Gosling about Java bytecode, which is not something you can use for JavaScript. It has types in every operation. So it's for a typed language like Java. But it was still a good paper. It inspired me to think about how to make JavaScript run fast. JavaScript doesn't have types, but if you write it carefully, you can have what turn out to be runtime types that check and validate. Here's an example from James Gosling's paper of Java, and it shows how the Java bytecode looks like a stack machine code with types for integers, and it has types for booleans and objects starting with A store, A load. There were issues with that bytecode, but when I did JavaScript in 10 days, I was told not only should I do it in 10 days and make it look like Java, but I should do a bytecode interpreter because Netscape wanted to have JavaScript on the server. That was the Livewire project. And they wanted to load bytecode so they have fast app startup on the web server side. They didn't want to parse the source as the browser does. So I wrote not only a front end, a lexical scanner and parser, I wrote a bytecode interpreter, and then I wrote something you have to get to turn bytecode back into strings for function toString, because I wanted the language to always show you the code it came from. If you had a function, you could turn it into a string and get the code back. And there was so little memory on machines that I couldn't save all the source code. It was just flying by as it loaded. So I made a decompiler, which was inspired in part by James' paper. I hardly had time for anything in the standard library. You wouldn't recognize some of it. There were arrays were hardly there. They just object with a length property. There was no array prototype sort method, as you'll see in a minute. And to make it look like Java, because we needed a date object, after the 10 days, somebody at Netscape named Ken Smith helped me by translating Java util date, which had year 2000 bugs and other problems. People hate the way it numbers months from 0, but days from 1, as you would expect. So like January is 0, and February is 1, and December is 11. That came from Java directly. It's been deprecated in Java. It's still in JavaScript. We should probably replace it with something. But people have things like moment.js to use now, so it's OK. There were mistakes. I'm not going to show you Gary Bernhardt's Watt video. You've probably seen it. It's very amusing. When I first did JavaScript, I had the C-like double equal operator. And I had operands of different types were not double equal because it didn't make sense. But my very early adopters inside Netscape said, oh, I want a form, an HTML form that has a string that contains a number to just be double equal to that number. Can I have that, please? And so foolish person that I am, I gave them what they wanted. And that's part of the fun with JavaScript with Brian LaRue and Elani's WTF.js. I've got to watch out. It's still up. But there was enough good there that it survived. And I'm going to show you a little bit of the early code. This is a single-page application from, I think, 1996. It's an artist's gallery using frames and frame sets. It loads all as one page. You can click on these links, and you get different artists' art. This is from the Web Archive, which started that year. You can see the links if you look closely. I don't know if you can see. They're JavaScript URLs. Here's the source after the initial Web Archive stuff that gets prepended. And there's a few things to note here. Because JavaScript was such a Rust job, so short on standard library, you had to write a lot of things for yourself, like a sort method. I believe there's a qsort in here. Let me see if I can find it. Maybe it's in the next one. If people can hear me, I don't know. It's OK. I don't mind the hand mic. It's good. You had to write, instead of JSON, you had to write your own constructors and call them, like new catalog. And I think we can see catalog back here. There it is, function catalog. So to make a catalog of artists' work, you would call these constructors with arguments. No JSON, but it worked. It barely worked. And people like the creator of this, Bill Dortch, could actually do compelling work, like this website. This single-page application. He didn't have XML HTTP requests. He would use background forms and link clicking automation. OK, so not only did I do the JavaScript language really quickly, I had to do the early DOM, the DOM level 0. And that turned out to matter a lot, too. So all the link automation and the form automation, all the things with cookies that you had to have to make a single-page application, that was all there in the early days. OK, onward. So things have evolved. One of the things that I did to make it look like Java or C was to add bitwise operators and the shift operators. That allowed us to have integer types in the language without being able to declare them. So that was one of the seeds I planted without really knowing what I was doing that grew into part of ASM.js, and it's led to WebAssembly, which I'll talk about. ES6 is done. I say all but done because the engines are still catching up. If you look at Kangax's GitHub, you can see his compatibility table for ES6, and it's coming along. I think WebKit has proper tail calls, tail call optimization, standardized, in progress. I think they had to turn it off temporarily, but they're pulling ahead of other engines in that regard. Typed arrays came in with WebGL, which is really awesome. Typed objects are coming, I hope, in ES7 or later. TypeScript. Does anyone here use TypeScript? Great. Anyone use Flow? All right. Facebook Flow, which is a more sophisticated type checker. So here's a version in ES6 of that Java code from that James Gosling paper. with a little bit of hand ASM magic to make it have integer types. So you can see those bar zeros, single bar 0, bitwise or 0, force the value to be a 32-bit integer. And you have to use them carefully. It's not really easy to hand code, but you can force everything to be in integer type space, and that allows you to validate and run fast as an ASM program. And so to take James' bytecode example, I put the ASM code next to it. Nice thing about JavaScript is you don't have goto, you don't have arbitrary jumps, so you don't get into the spaghetti code verification problem Java got into. Everything's structured. And so it turns out JavaScript, even though it's untyped, has a typed subset with deterministic performance. And if you use it, especially if you cross-compile code to it, you can get really good performance. People have been doing this for a while with GWT, Open Laszlo. CoffeeScript, which I think ES6 has sort of taken the oxygen from, Dart, which is now compiled to JS language, and the solar system of JS. I'll just go quickly through this. This is a nice Clojure script application by Sean LeBron. It shows how JavaScript has evolved to be this giant sun with a core that was stable long ago, ES3, ES5, which came out in 2009, ES6, ES7, let's hope. It's going to be 2016. Some things in there might happen, might not. We're on a rapid release cadence I'll talk about too. Everyone's using tools. Who's using Babel.js out there? Many people. Anyone using something other than Babel? There are other options, but ESLint, ESHint, JSHint, I mean? Yeah, okay. Anyone using JSLint still? It's a little bit harsh. So now the sun is the center of this larger system where people are adding static typing. I mentioned TypeScript and Flow, and there's interest in the committee on standardizing something, but it's too early, and these languages, these checkers, these are really languages, type systems, are evolving too quickly to standardize. Google's Clojure compiler is also evolving. And then there's this SoundScript experiment in V8, which is moving along. It is an attempt to put some kind of typing into the language itself, into the VM, into the V8 engine. And the ECMA committee is supporting it. We're trying to see if we can agree on what that type system is. It depends on a sort of strong mode, which tries to clean up some of the semantics. It makes objects or classes sealed by default, things like that. We need a lot of user testing to be sure that's even going to be acceptable to the community. But it's a good experiment, and I hope it gets to a point where we can make a decision, because people still want to standardize types. They're tired of using checkers, ahead-of-time checkers. And there's CoffeeScript, Dart, of course, Clojure script with a J, and lots of things. And Scripton is notable here because it's the cross-compiler from C++ or C to ASM.js, and we hope to WebAssembly. So let me go back to my slides and quickly progress from here. So Scripton, by Alon Zakai, Mozilla Research, has been hugely influential, and it's used by the big game companies now, by the game engines, by Unreal Engine from Epic Games, and by Unity. Those are both supporting ASM.js and WebGL as targets, just like they support PlayStation or Xbox. So I feel like Java was supposed to be the big brother language, but JavaScript grew up, and it learned Kung Fu, and it kicked Java's butt. Java is doing fine on the server. It has, dynamic language support thanks to this DaVinci project that was done a few years ago. In some ways, you can run dynamic languages on the JVM. You can run static languages on JavaScript VMs. So I guess that makes Obi-Wan James Gosling, and I'm Darth Vader. That's not what I wanted. But ASM.js was hugely important. People underestimate it. They think, oh, it doesn't really work, or it only works well in Firefox. It's not true. It also led the way to WebAssembly, which was announced this past spring, because I think the V8 people and the portable native client people at Google realized that there was no point in trying to do a second runtime. Dart had already come to the same conclusion. And instead of trying to do something in addition to the JavaScript VM, why not just evolve the JavaScript VM to support a new richer syntax for compiling code and new APIs that you might not want to put into JavaScript. So it's coming along. People don't know this because a lot of the work is detailed specification work. There's an OCaml spec, if you can read ML. There might be something in my slides later that looks like Pascal. It's really ML. And Microsoft is on board. I'll give you a tweet testifying to that. The idea with WebAssembly is it will be the second syntax for the standardized JavaScript virtual machine, the engine that we all have in a browser. And there are multiple engines, multiple implementations. But so far, you've only been able to talk to them using JavaScript syntax. With WebAssembly, you'll get a second syntax. It'll be much more concise, especially for compiling C++ or other languages like that. One VM, two syntaxes, .js and .wasm. And what does it look like? It's hard to see. This is from one of the prototype implementations on the GitHub for WebAssembly, github.com WebAssembly. It shows a bunch of opcodes in an enumerated class that fits in an 8-bit integer. This is just for the operations on 32-bit integers. WebAssembly is like a bunch of operations for 32-bit integers, 32-bit floats, and 64-bit integers, 64-bit floats, which means 64-bit integers are coming to JavaScript, I think. But they're definitely in WebAssembly. You need them on modern architectures. And here's a bit of code that translates from WebAssembly back to JavaScript. You can see things like negating a number is just minus on the far right there, third line. And bitnod is tilde. And there are some idioms from ASM.js like tilde for converting from a 32-bit or 64-bit float to a 32-bit integer. That's the cleanest way to do it. Here's a piece of ML from the specification. If you don't know ML, don't worry about it. It's not the complete list of expression types, but it's almost complete. It's a very small language, and it compresses into a binary syntax. It's very efficient. I can't demo it yet because the engine support isn't quite there, but there are implementations coming along in JavaScript Core from Apple, in V8, and in SpiderMonkey from Mozilla, and I think there's one from Chakra. Let me see. Here's a tweet from Gaurav Seth of Microsoft. He said, "We are all in and working towards it," about WebAssembly. So everyone's on board. Christian Heilmann, who used to be at Mozilla, is at Microsoft. He should know better. I think he was just giving a softball to the WebAssembly people. He said, "It got silent around WebAssembly, or am I just missing something?" Well, hard work doesn't make a lot of noise. So the hard work is going on in the GitHubs. And you can see these repositories. You can go to them if you want. So github.com/WebAssembly. There's a community group you can join if you want to contribute. And there are contributed projects under this, repositories under this account. So people are doing things like LLVM backends. There are 3 of them. One, I think, from Apple, and one from Google, and one from a volunteer contributor. So people are jumping on board. ES6 is part of this rapid release process I alluded to. We're trying to get the standard out every year. We'll see if we can do it. That might mean that ES7 2016 is going to be small. It should have at least this. This is something we've been working on to make, I'll skip to the part where you can see the payoff. You see async in front of function, and you see await down there when it's calling the animation callback, anim. So this is better than using yield. You don't have to write generators. You don't have so much boilerplate. People are used to async await or variations on it from Dart and C#. And this is something I think definitely should be in ES7. And there's more. SIMD is also coming along. That might be ES7, ES8. It's not clear. I'm going to use the short ES numbers because it's very confusing to use the years. It takes too long. We want to have 64-bit integers, I mentioned, but also other numeric types. And maybe, as Sean LeBron speculated in his solar system of JavaScript, we'll get to the promised land of macros. Hygienic macros, as in scheme. Then the circle will really be complete. So you can do things, even several years ago with this ahead-of-time tool, Sweet.js, you could make a macro for class definitions. Then you could write a class, and it would just expand the macro into the constructor pattern that we all know, which is pretty awesome. I'm going to give some demos quickly. Maybe I will use the other mic. Yes. Thanks. So this is just Dead Trigger 2 from Unity. You can run this in Firefox nightly. It's a zombie game. I don't know if I have audio. I do. I hear it down there. Can you put that on the speakers? Uh-oh. The best thing about this game, the sentry chickens. They'll take care of any zombie problem you might have around your house or farm. The sad thing is the machine guns overheat and explode occasionally. And you have to respawn the chickens. I don't have to do anything. It's pretty good. I don't want to create too much bloodshed here. And sometimes you can find some golden pigs that have a lot of money. The zombies are carrying cash. They're very smart. They're ready for anything. This guy's a tanker. He's gonna cause problems. Where is he? Oh, he's coming over here. If you get too close, he can hurt you by exploding. So it's best to use grenades. If you have grenades. There you go. All right. That's all automatically compiled from C++ to JavaScript. OpenGL to WebGL. There's no extra hand porting anymore. It's all part of the Unity 5 product from Unity. And before we did that, we did Unreal Engine, which was also pretty awesome. We met with Tim Sweeney and everybody in North Carolina and the United States, and we did Unreal Engine 3, and now they're doing Unreal Engine 4. And so here's a demo of the Sanctuary level of Unreal Tournament. And I'm going to go full screen. This needed a lot of evolution of the web, like Gamepad API, full screen API. Web audio had to come to other browsers, but everyone's on board now. Skip the fly through. You can see my mad skills. I don't really practice games much. It also helps. Thank you. I know I'm full screen. Thank you. Now I have to dismiss it, I think. There we go. Don't shoot me. I think I'm invincible, fortunately. All right. I seem to be stuck in a pit. I'm going to go back. It might be the screen resolution's messing it up, but try again. This was never released. I think this was just demoware on Unreal Engine 3, but they're going for Unreal Engine 4. Yes, thank you, full screen. All right. I might have to do fly through and then, right, transition in. Oh, and the nice thing is I can not be violent. I can go sightseeing and go around the outside here. Syntax drew first blood. Well, that's the way it is. All right. Yeah, my gamepad's not working for some reason. I'm going to go to another game. This is Banana Bread. This is a demo from Mozilla Research that has an outer game that's based on the Cube 2 engine, Sauerbraten, and it has an inner game, which is the pre-version of Doom. Has anyone seen this? This is where you can do 2 games in one. You can do sort of game inception. I still have this heads-up display here. All right, I'm going to go back and start this one over, so I don't have to have that thing in my way. The fun part about this is when you can play the inner game from the outer game, while the outer game has a bot that's trying to kill you. It's actually not very fun. I'll have to turn it off before it kills me because I'm not very good at the outer game. So what level should I play? Second episode? Please don't kill me. Thank you. Uh-oh, here comes the bot. Remove bot. Whew, okay, good. Now, in the inner game, I think I use the arrow keys. Oh, and there's somebody here shooting me. No. And I use control to fire. Yeah. Oh, come on. Yeah, there we go. And I use, yeah, the outer game is WASD. The inner game is arrow keys. And I should be able to get through this door if I bump on it. Yes. Uh-oh. Run away in both games. You can see shooting in the outer game doesn't do anything for me. Anyway, that's glued together with about just a couple hundred lines of JavaScript, which is really cool. It's easy to do. There's a worker that runs the Doom game, and there's a canvas that it renders to. and the rendering events get forwarded to the canvas in the outer game. So you can glue games together that were written totally independently, never meant to be composed. That's the power of the web, the power of mashups. And I think that's all I'll show you, though. The zombie game's a lot of fun. I'm going to leave this mission, go back to a different one. This is where you have some scientist friend, Dr. Adamos, and you're supposed to save his life. I'm going to use chickens again, because those zombies can swarm. And Dr. Adamos is not very good. He just runs out of ammo. He kind of sprays and prays, and then he just sits around asking for help. Here he is. Okay, dummy. Don't get eaten. I'll show you one of the golden pigs. I don't know why the zombies have so much money. I wonder if they have 401k plans. Anyway, there's a pig. All right. Golden pig. Oh, leave me alone. And if you get the pig, he oinks and you get the money. All right. Games. They're kind of necessary to prove the platform is complete enough. And so that's why, in spite of people disbelieving for years, I made this slide in 2010 when we were worried about Dart. And I remember being worried about Flash and Silverlight in 2006 or something. They all yielded to JavaScript. So always bet on JS. Thank you very much.